Hello everyone and welcome to today's webinar. My name is Abhilash and I am from the AD Solutions team. Now before we jump in, I'd like to thank you all for joining in. Thank you so much for taking out the time. So yes, today's webinar is about securing hybrid identities with two-factor authentication and advanced password controls. Now the reason I have picked this topic is because user logons and passwords, they are the baseline, right? They are the first line of defense for any organization security. And if a malicious user can gain access to your internal network, that could be the end of things, right? So with that being said, all the sources or the source links are embedded within the slides, and the slide deck will be emailed to you as soon as the webinar is done. All right, so let's take a quick look at today's agenda. I will be talking about today's attack landscape, right? The attack landscape of 2019, because technology has evolved and so have attacks. Attackers have gotten sophisticated, and more importantly, attacks these days have gotten extremely easy to perform, right? And then I will be talking about the various challenges that come with a hybrid setup, after which I will be showing you a live simulation of a security attack. Now, the reason I'm showing you this is to prove a simple point, right? That you needn't be a hacker, you needn't be a professional to perform an attack. All you need is some computer, is some internet, and some motive, right? And then I will be sharing with you a few tips and techniques that we could employ to harden our security foundation. And finally, how ADSelfService Plus can be leveraged to overcome all of these problems. Okay, so this is the attack landscape of 2019. Attackers have gotten extremely sophisticated, and it's not like the olden times where attackers only used to target the top-notch celebrity companies, but the smaller thriving companies, right? They are an even better target these days. Because have a look, on April 15, 2019, Microsoft was subject to a data breach, right? And this breach basically happened where a hacker got access to a support personnel's credentials, right? And the hacker was in the network for a period of 6 months, right? Please note the time. The hacker was in the network for 6 months and Microsoft didn't have a clue, right? The Verizon's 2019 report, the latest data breach report that came out, states that 56% breaches took longer to discover. 52% breaches involved hacking, right? Involved using of user credentials to gain access to the internal network. And 43% breaches involved the smaller business victims, the smaller thriving companies, right? And this is an accurate description of today's scenario, because it's just not Active Directory anymore. We are slowly tending towards these cloud-hosted applications, right? Applications like Office 365, like Exchange, like Salesforce. The reason we are doing this is actually pretty simple. We have the need, we have the necessity to get that extra help, right? To get that extra push so we can stay ahead of our competitors, so we can stand out in the big game, right? So we end up taking support from these third-party providers. And the most important thing to note here is for all of these applications, the central point, right? The central point for authentication and authorization is Active Directory, right? Active Directory authenticates and authorizes users across all of these applications, right? Now, according to me, there are two pieces to the hybrid puzzle. The first piece is the workload, right? How is the workload distributed across these applications? Which application handles the most workload, right? And how are the security parameters across these applications? And the second important part of the hybrid puzzle is the user data. Data is the new cash, is the new commodity in today's IT industry, right? User data is the one thing that you will want to protect. So the idea I'm trying to project here with all of this information is we need a right mix, right? A right balance of security and control over both our in-house environment and our cloud-hosted environment, right? Now, a question that I find myself asking way more than often is what challenges come with a hybrid infrastructure, right? So The first challenge and the simplest of all is Windows domain single sign-on. Right now, let me illustrate this using an example. This is a fine Monday morning, right? A user has logged on to his or her domain join system. Right now, let's say the user has worked across 4 to 5 cloud hosted applications. Now, 4 to 5 is a very liberal number that I'm taking, but organizations use at least 10 to 12 cloud hosted applications. Now, please take a second, put yourself in the end user shoes and think about how difficult this can get for your end users, right? So essentially, a user has to remember multiple sets of usernames and multiple sets of passwords across cloud hosted applications, right? And let's leave the user comfort part alone. Let's jump into the user security part. Now, when a user is forced to create passwords across multiple cloud hosted applications, he or she will set weak passwords, right? Because these cloud hosted applications, they do not have a strong password policy, right? And I personally believe that the password creation guidelines are not good enough to create strong passwords, right? And the second challenge that comes with a hybrid infrastructure is your employees. Your employees use a mix of on-prem and cloud hosted applications. For example, your sales employee probably uses the Salesforce application. Your developers probably access the HackerRank application. Right now, it's the administrator's pain to sit back and figure out access for different employees in the organization accessing different cloud applications based on their job function, right? And the third challenge that comes with a hybrid infrastructure is security. Right now, we have been working with our traditional in-house setup for years and probably decades now, right? And with the sudden introduction of these cloud-hosted applications, we might want to set up some kind of control, right? Some kind of security, right? Two-factor authentication, for instance. But the problem here is most cloud applications, they don't even support two-factor authentication, right? And how do we set up two-factor authentication for users who access the network remotely? And the second point comes into the picture again, where the administrator has to set up two-factor authentication for different users accessing different applications based on their job function. Right now, a question that I find myself asking way more than often is whose responsibility is it to secure users across the hybrid setup? Right? Is it the administrator's responsibility? Is it the cloud provider's responsibility? And the answer to this question is joint hands, right? It's the administrator's responsibility to set up strong security policies, right? To ensure that his users are accessing cloud applications on an authorized basis, right? It's the end user's responsibility to use secure passwords, right? And it's the cloud provider's responsibility to secure their customer accounts, to secure their data centers, right? And it's joint hands, like I always say, gives us the ultimate security, the ultimate control that we need, right? Now, time for the surprise part of the presentation. I will be performing a live attack on the Outlook Web Access Portal. Right now, the reason I'm targeting the Outlook Web Access Portal is email, right? Users use email all the time, right? Your administrators, your users who are always on the move, right? Your in-house users, everybody uses email. And why Outlook Web Access Portal? Because it comes free with the Exchange server. Right now, this attack will be performed by a user who has absolutely no privileges, right? So just a regular domain user logging onto his domain join system can perform this attack. So let's go ahead and perform the attack. I will quickly log into my VM here. So here is my VM, right? And let me quickly show you something. If I open up PowerShell, we can see that I am logged in as a user called James. And let me show you something. That's net user James, right? Check this out. This is James's membership, right? James has no local group memberships, and the global group memberships is just domain users, right? James is just a member of the domain users group and has absolutely no privileges, right? So before we perform the attack, let me show you three important things. The first thing is the mail sniper module. Now this module is available free over the internet, and I have embedded the source link within the slide. And the second important thing is a text file that contains a list of probable usernames, right? Friends that you know that are probably working in that organization, right? A simple LinkedIn search can give you a list of connections that work in that organization, right? And then a list of probable domain names. The name of the company is generally the domain name, right? There are PowerShell scripts that can be used to guess domain names. There are tools online that can guess domain names based on certain parameters, right? So let's go ahead and perform the attack. So if I open up PowerShell, I will be running a command called PowerShell.exe-exec and then bypass. Right now, the reason I'm running this command is because PowerShell does not let you run scripts that are not digitally signed, right? That are not authorized from Microsoft. So running this command enables your end users to run any script from an unknown source, right? Any malicious script. So once this command is run, now we have the rights to run any script that is not digitally signed. Let me quickly shift to the desktop. Okay, now that I'm shifted to the desktop, we are going to use these three modules for this attack, right? So let me quickly import module and then /mailsniper.ps1, right? That's the module on the desktop right there. Once I import, the next thing we are going to do is invoke domain harvest OWA. Right? You guessed it, we are performing the attack on the Outlook Web Access Portal, right? And then the Exchange hostname, the name of the server that hosts Exchange, right? So that's VMware PPM-EX13. That's the name of the server that hosts Exchange, right? And the next thing is the domain list. Domain list is nothing but the list of domain names that I just showed you. Here we are, right? So what we do is right click, properties, security, and let's just copy the path of the file, right? Copied and paste. Very good. And now what we do is once I hit enter, we can see that the script is being run against all the possible domains in the text file that I just showed you. And within seconds, we have the name of the domain, right? So that's perfect. The next thing we're going to do is invoke username harvest OWA, right? And then the same process repeats again. So that's exchange hostname, which is VMware PPM-exchange13, and then user list, right? User list is the list right here. So that's the same path again, but change the domain list to the user list, right? So that's user list.txt. Right, now that we have given the path, let's use the domain name that we found, right? So that's domain vmrppm.com, right? So once I hit enter, we can out this file to a text file. So let's call this valid users, right? And once I hit enter, we can see that the spray has started and it says that it has found a total of 2 valid usernames, right? But please take into account that we need to go with the response time, right? So the lower the response time, the more valid the user is. In this case, Luna is a valid user, right? Because the response time is just 42, and so is Brad, and so is Jules, right? But if the response time is as high as 120, it means the user is not valid. All right. Now that we have found valid usernames, let's go ahead and invoke password spray OWA, right? We are going to perform a password spray attack on all of these users, right? So that's invoke password spray. The same process repeats again. That's exchange hostname, VMware PPM-EX13, right? And let's give in the user list, right? The same list that on the desktop, right? So that's user So list.txt, once we have given that, let's go ahead and give in a password, right? Let's give in a common password pattern. Let's say password at 123, right? Now, once that's done, let's go ahead and give in the domain name again, which is vmrppm.com, right? So that's invoke password spray, the host name, the list of users, the password, and the name of the domain. And once I hit enter, we can see that the spray has started and Microsoft is trying to block the attack, right? It's trying to say that this script is malicious, but please take into account that the script is still running in the background, right? Microsoft is trying to block it, but the security is simply not strong enough. So the script is still running in the background, and here we are. We have gotten two users, right? That's Jules and Brad, who use a common password pattern like password at 123, right? So now we have a user and the user's password, so we can potentially log into the network, right? So let's go ahead and do something. Since we can log in as a user, let's go ahead and perform a global mail search, right? So what I will be doing is invoke global mail search, right? And then the same thing again. So that's exchange hostname, vmrppm-exchange13, right? And now please pay attention. We will be giving a command called impersonation account. So what's going to happen is the user logged in, right? James in this case is going to use the admin credentials to impersonate himself as the administrator, so he can get the mails that are being sent inside the organization, right? So that's impersonation account, James, and we can output this to a CSV file. So let's call that mail data.csv, right? And once I hit enter, all right, so let's just check the command again. All right, so that's output CSV, not out CSV. And once I hit enter, we can see that it asks for my credentials, right? So let's go ahead and just give in, say, Brad's credentials. So that's Brad and password at 123. So I can give in Brad and password at 123, right? And once I hit OK, check this out. Please pay attention here that using James to impersonate Brad, right? So James's account is being used to impersonate Brad's account, right? And let's just wait for a second. Now what's going to happen is the mail search is going to run through all the mailboxes in the organization and push out emails that have two terms, right? That's username and password. So any email that is being sent within the organization that has the terms username and password will be pushed out after this is run, right? So what's going to happen is all the inboxes inside the organization are being run, and once the run is done, here you are. All right, results have been output to mail data.csv, right? Brad at VMware PPM for the terms password, creds, and credentials. Okay, so let's go ahead and check out what's in the CSV file, right? So here we are, and check this out. We have gotten a mail sent from the administrator to Brad that says, login information for CRM system. Hi Brad, please find your login details for your new CRM account, right? That's the username and that's the password. Regards, system administrator, right? So we potentially went through the mails that are being sent inside the organization, and we were able to push out mails that have the terms passwords, usernames, creds, or credentials, right? So how did the attack pan out? We started off with basically no information, right? We didn't even know the domain name, right? So we started guessing the domain names. And once we found a valid domain, we started guessing a bunch of usernames, right? And once we found a valid user in that domain, we performed a password spray attack using a common password pattern like password at 123 or admin at 123, right? And once we found a valid user, we use that account to read through all the mails that are being sent within the organization, sensitive mail data that is being passed within the organization, right? So what caused this attack? Two problems actually caused this attack, right? The first problem is that our cloud applications are not well protected, right? We saw it. We performed the attack on the Outlook Web Access portal of an on-prem Exchange server, right? And the second problem is that the passwords we used, they are extremely weak. They are extremely vulnerable, right? Had we used strong passwords, this could have been a partial win-win for us, right? So a few tips that we can employ to protect our cloud hosted applications. The first tip is employ two-factor authentication, right? Because we saw it, using the username password combination alone just won't cut it, right? We need a secondary mode of validation that double checks the user's legitimacy before he or she logs on to a domain joined system, right? Tip number 2 is centrally managing access. The truth is, organizations are using a multitude of cloud hosted applications, and the administrator has no central dashboard via which he or she can assign or revoke access easily, right? Tip number 3 is just disable PowerShell, right? If your end users do not need to use it, please disable PowerShell, right? And if they do need to use it, please set up authorized access, right? And tip number 4 is use a SIM solution. A SIM solution basically gives you details about who, what, and where of the attack. Right now, we do have an in-house SIM solution called Event Log Analyzer, and I have left a link to it within the slide, so you can download it and you can test it out in your environment. Okay, so let's go ahead and set up two-factor authentication with ADSelfService Plus. But before we do that, a quick look at ADSelfService Plus. It's an end user, right, self-service password management tool. So it basically helps your end users to unlock their own accounts, reset their own passwords, and fill in their own personal data, right? It is also a single sign-on solution and a 2FA solution for Windows and Mac logons, right? So let's go ahead and set up two-factor authentication with ADSelfService Plus. So if I head into my browser here, and here we are, right? I am logged in as the administrator, right? So all we have to do is head into Administrative Tools, GNOME Linux, and Windows Logon TFA, right? And once we hit Enable, that's it. Two-factor authentication will be enabled, but please ensure that you have an SSL certificate installed, because we want this process to be secure, right? For which we will need the HTTPS protocol, right? And once that's done, let me quickly show you something. If I head into policy configuration under self-service, right? And if I hit on advanced and login TFA, right? This is where you can set up the methods for two-factor authentication, right? All you have to do is check the box and enable it inside Administrative Tools. And let me quickly show this to you in action. So this is how it would work, right? So a user is logging on to his or her domain joined system. So he or she enters the password and the ADSelfService Plus portal opens up, right? In this case, the two-factor verification mode that we have set up is an verification code that will be sent via email, right? So the user will get a verification code on his or her email. And once the user enters the valid verification code, only then will he or she be allowed to log on to his or her domain joined system, right? So that's one time entering the password, two-factor authentication to double check the legitimacy of the user, and that's it. The user can access the domain joined resources, right? So how does this actually help us? This helps us because cloud applications, right? Most applications like Exchange or SharePoint, right, use Active Directory as the mode of authentication and authorization, right? So by setting up two-factor authentication at the login screen, we are double checking the user, right? And this secures access to Active Directory resources, but at the same time, this also secures access to your on-prem applications like Exchange, like SharePoint, right? But you might ask me a question. The problem where a user has to enter his or her passwords multiple times is still not sorted, right? Now, granted that we have secured access at the login, but passwords still need to be entered multiple times, right? And what about applications like Office 365 or Salesforce or SSO? Because these applications do not use Active Directory as the mode of authentication and authorization, right? These applications have their own mode of authentication. Right now, that's when single sign-on comes into the picture. Right. So what happens here is the user logs onto his or her domain join system with a password, undergoes two-factor authentication, and that's it. Because we are combining single sign-on with two-factor authentication, the user only has to validate himself or herself one time, and the user can have seamless access to all of the cloud-hosted applications. Right. Now, let me quickly show this to you in action. If I head into my VM here, all right, now I am logged in as a user called Brad, right? So here we are. Now, Brad has access to an Office 365 portal. So Brad has an Office 365 account. Right? So Brad opens up his web browser, and all Brad has to do is head into ADSelfService Plus and check this out. Brad is logged into ADSelfService Plus, right, without entering his password. The reason is because the authentication is already done at the login screen, right? So that's password entering at the login, two-factor authentication at the login, and that's it. Right now, all Brad has to do is head into applications and simply select the application he wishes to access, right? And we can see that Brad is logged in to Office 365, right? So this is one-time login, one-time verification with two-factor authentication, and that's it. Seamless access to all of the cloud-hosted applications. All right. So a quick recap of what we saw. We saw how to protect our logins with two-factor authentication, right? So when a user logs on to his or her domain join system, he or she undergoes a secondary mode of validation. So this in turn secures access to our in-house resources, our AD resources, and our on-prem applications. And by combining two-factor authentication and single sign-on, what we have done is we have secured access to all of the cloud-hosted applications, right? Applications that have non-AD based authentication. So what we've done here is we've directed the logins of all cloud applications to one central point, right? That's Active Directory. So we made Active Directory a central point of security. But the problem here still stands. Why do I say that? It's because we are still using weak passwords. Right now, this attack that we just saw is just one form of an attack. Right? But when password attacks happen, they can come in more than one form. Right? So the first line of defense, like I said earlier, for any organization is using strong passwords. So the fix for problem 2 is we need to implement stronger password controls. Right? Now, when I say stronger password controls, I just don't mean setting stronger policies, but implementing policies, advanced policies that are in accordance with today's password requirements. All right. So why do we need a strong password policy? Active Directory's password policy has been around from Windows 2000, right? So that's more than a decade, more than 14 years of using the same 6 password settings, right? There hasn't been a single update. There hasn't been a single change, right? And the problem with the password policy is that it works on the domain level. So your domain users, your critical, your sensitive, your privileged users, everybody have the same password policy settings. Right now, I understand that Microsoft gave us fine-grained password policies of password settings object to be more precise, but the problem is they still have the same old 6 settings. The settings, the options that are a decade old. Right? Now let me quickly show you something. If I head into my domain controller right here, right? So I am logged in as an administrator. Let me go ahead and reset a password for Gabriel right here, right? So let's right click, reset password, and password at 123, right? Password at 123, and once I hit OK, we can see that the password has been changed, right? So let's go ahead and reset the password for Gabriel again. Now Gabriel is a very forgetful person, right? So that's password at 123, password at 123, and once I hit OK, check this out, password has been changed again. Right? Please take into account that Active Directory does not track the passwords that are being used during reset. Right? So we can reuse a password how many ever times you want during reset, and Active Directory does not track that. Right? Active Directory does track the passwords that are being reused during change, but the problem is it still lets us get away with passwords like password at 123. Right? And we saw it. There are attacks based on password patterns such as this. Right? Now, you might ask me, how can password attacks happen? Right? How else can password attacks happen? Right? To understand that, we need a quick jump back into history. How are passwords stored? Right? So whenever a user logs on, Windows creates password hashes. Right? There are two kinds of hashes, NTLM hash and LAN manager hash. Right? The NTLM hashes are stored in the LSA in the SAM database, and the NTLM hashes are stored in the ADSLS.RIT file, and the LAN manager hashes are stored in the SAM database of the LSA. Right? So how do attackers obtain these hashes? So the methods used for obtaining these hashes are actually pretty simple. Right? So they obtain the password hashes using tools that are given by Microsoft. For example, NTDS util, NTDS audit tool, right? Or third-party tools like Mimikatz, right? And once the hash is obtained, they can crack the hashes. K-enable can help with this. There are online tools that can be used to crack password hashes because they check the hash and they run it against multiple dictionaries, right? So this is an example of a parser hash attack, right? This is how an attacker can obtain a user's hash, can steal a user's hash, and then abuse that hash to gain access to the resources that the victim user actually has, right? And what does the domain controller think when the attack is happening? It's the victim user who is actually requesting the access. Right now, we do have a few tips that we can employ to set up stronger passwords. Right, so the first tip is adopt the 8+4 rule. Right, so the 8+4 rule is basically use uppercase characters, lowercase characters, numbers, and special characters, but ensure that you mix and match them to create a strong password pattern, right? Because password at 123 has all of these patterns, right? All of these characters are there in that password, but the pattern used is very easy to crack, is very recognizable, right? And the second tip is adopt passphrases. For example, the sun will rise again tomorrow, right? This is a passphrase that can be used because you can pick a word, a letter from each word, mix and match them with numbers and special characters, so you can create a strong password pattern, but at the same time, the pattern can be easy to recollect, right? So this is a strong password that is easy to recollect, right? So the third point is adopt MFA and TFA, and please set a number that will lock out a user, right? Because most brute force attempts, most dictionary attack attempts happen when there is no lockout threshold, right? Point number 4 is encourage weirdness. If your users can come up with quirky password names, please encourage that and adopt stronger password policies for your sensitive accounts. Right? I cannot stress on these points enough. Your sensitive users, your privileged users need to have stricter password policies than your domain users. Right? And finally, educate your end users. Right? Your end users need to be educated. They need to know how to treat their passwords with utmost importance. Conduct training sessions, send out emails, ensure that they know the importance of using and saving a strong password. Right? Now, we do have a tool called the weak password reporter tool that can be used to check weak passwords in your domain environment. So what this tool does is it compares the password hashes of the user, right, with the plain text password that you've given. So it compares both the hashes and it gives out the matching password hashes, right? So if the password hashes match, meaning if the weak passwords are used, the tool will give out the usernames, right? So let's go ahead and set up strong password policies with ADSelfService Plus. So let me quickly head into my browser here, and this is ADSelfService Plus, right? So if I head into self-service and password policy enforcer, this is where strong password policies can be set up. Now, these are settings that are in accordance with today's attacks, that are in accordance with today's security requirements, right? For example, minimum password length. You can set a minimum password length. You can disallow the usage of palindrome passwords. You can set the number of numeric characters that can be used in a password, right? You can disallow the use of characters from an old password or from a username, right? You can ban the use of dictionary words, right? Because check this out. These are all the words that come within a dictionary, right? So an attacker can potentially run an attack with all the words in a dictionary. So you can add in your own sets of words to this, or you could put in your own customized dictionary as well, right? We can disallow the usage of certain patterns. For example, password at 1, 2, 3, right? Now let me quickly show you something. If I head into my DC here, right, and ADSSP1, that's my OU right here, and once I hit right click and reset password, right, so I am resetting a password for P, right, so that's password at 1, 2, 3, right, password at 1, 2, 3, and once I hit enter, check this out, Active Directory throws you an error. How has this happened? Because we have enforced the password policy from ADSelfService Plus. Right now, please take into account that policies can be applied on users, groups, and OUs, right? And the password policy is not a replacement for your domain password policy, but it actually works on top of your domain password policy, right? It works in cohesion with your domain password policy. And this policy works directly from your GNACP, which is your login screen. It works from your native ADUC password resets as well. We just saw it. Okay. So a quick summary of what we just saw. We saw how a domain user with absolutely no privileges can perform an attack, right? And in order to combat that, we split the problem into two parts: two-factor authentication and weak passwords, right? So we implemented two-factor authentication with single sign-on. So this secures the user's access to on-prem AD resources, on-prem AD applications, and any cloud applications configured within ADSelfService Plus, right? And that does not cut the problem. What we need to do for a complete solution is we need to employ stronger passwords, right? So that's stronger password policies plus two-factor authentication that can give us all-round protection, that can give us the security, the control that we need. Okay, so thank you so much for listening. My name is Abhilash. My email ID is abi@manageengine.com. Right? So if you have any questions or if you need any information whatsoever, please drop me an email and I'll get in touch with you very soon. Thank you so much. Have a great day.